as we had built out a set of these solutions for customers, there was a different suite of software that would have been optimal for them. And picking that for them sort of and say, this is the Pratexo platform, didn't seem wise. To give you an example, we built a system for augmenting dogs. Basically, what we do is we put a compute unit on a dog, and it has a camera and has a set of sensors that can measure sound and everything in the environment, and a GPS and so on. And we're trying to aid the handlers of those dogs to see what the dog is doing, whether the dog is tired, whether the dog has seen something. We even do AI at the edge here with image recognition and so on. So we built this system for a dog, but what's most important there? Well, it turns out to be weight. A dog can only carry about 10% of its weight. So to minimize weight, we needed a smaller compute unit, right? So the idea of running Kubernetes all of a sudden became an issue, because that meant a much more powerful unit than we needed. It meant that the battery packs, in fact, this is the battery pack we happen to use for this. It's a very small battery pack, but it could drive for about 6 hours now, because we optimized for power consumption and weight. Our sensors were based on weight. Our compute units was based on weight. Our software was based on the most efficient way of doing things. That's very different from, say, we wanted to build a system for threat recognition on large vehicles, or maybe something on autonomous vehicles, let's say. We want to put something in a truck. Well, nothing is going to, weight is not a big deal, right? I mean, it will increase the energy consumption there too, but it's not important. We can put a very big compute unit in. Sometimes Kubernetes makes sense. Sometimes Kubernetes does not make sense. Sometimes we rather create a swarm configuration. So we wanted to be able to give our customer a custom platform, but not custom such that we had to build it from scratch. But it's a little bit like, well, I hate to use the word Legos because that's so misused in this space, but it's about putting together a set of software components that make sense for a use case. And of course, we can give you a template that says, oh, this is something we actually built for smart building, or this is something we did for the service animals and so on. We can put together a configuration so that you don't have to build everything from scratch. But you should also be able to pick and choose which software components goes into your configuration, right? We can assemble that platform for you and configure everything from deployment script to CI/CD pipelines to documentation about the platform, and incorporate your components into that platform if you have them, or give you a good start on writing those components. And we can do so really quickly, and so that when we have defined that and we have a visual way of sort of composing things and putting things together, we can push a button, and then when maybe go to lunch or have a cup of coffee, and then when we come back, we will have provision all the deployment scripts for you. And deployment turned out to be an absolute nightmare in this space, which we've had to spend, I would say, years of effort on solving, or the CI/CD pipeline, or simulators, or documentation, and so on. And think of it as buying a computer from one of your favorite computer vendors, let's say Dell. If you go to Dell today, you'll be asked, oh, is it for work? Is it a gaming machine? What is it? Oh, here is our recommendation. Now you pick one of these. Oh, if you're going to use that graphic card, you really need this memory. And you used up your slots for hard drives or whatever it is, but they have a configurator, and we call it a configurator, right? It is our platform configurator. And it allows us to build a platform, or a customized configuration of software components that will work specifically well for your use case.